Hello and welcome to the mathematical closure property. Now this property is not like what you would think in normal life where you just say like, oh, we broke up and now it's awkward and I just need closure. I don't know how to talk to you in the hall anymore. Are we still friends? Or like, I don't know how the story finishes. I just need closure on this. Or it's just not quite finished and something's like just left incomplete. I need closure. That's the way we normally think about closure. But in math, the property of closure is a little bit different. What the property of closure means is that items within a set, if you were to manipulate them, add, subtract, multiply, or divide them, the answer you would get would still be in that set. If that's true, then we would say it has closure or that it is closed. So it looks something like this. We say the closure property holds for some sort of operation, let's say addition of some sort of numbers. We will say rational numbers, let's say. What that means, what we're really saying is that whatever this is here, a rational number and a rational number equals a rational number when we add. So when we say the closure property holds for addition of rational numbers, what we mean is if we have a rational number plus a rational number equals a rational number, that the answer we get is something that's still in our group of numbers or still in our set. So, and this can be addition, this can be subtraction, multiplying, or dividing, this could be any type of numbers, but whatever it is, whatever word we're saying here applies to each kind of number, and whatever operation we're talking about here would go here. Multiply, subtract, divide, anything like that. So let me show you two examples. Let's think about even numbers. We might say, let's test. Does the closure property hold for addition of the even numbers? Which means really what we're asking is if we have an even number plus an even number, is that equal to an even number? That's really what that's really what we want to know. If we have an even plus an even, does it equal even? So as you think about even numbers, let's say we had 4 and 6, well, that's 10. How about 8 and 10? That's 18. If I pick example after example after example, if I add two even numbers, will I get another even number? What about this? That's still -2, that's still even. So an even plus an even equals an even. So we would say, great! The closure property holds for adding or for addition of even numbers. And we can test all kinds of operations with even numbers. What about multiplying? Does that work? Is an even number times an even number still equal an even number? How about 4 times 6? 24, yep, that's even. How about 2 times 8? Yep, that is 16. Check. So I think the closure property holds for addition and multiplication. And we could do subtraction or division here as well and get the same kind of thing. This is how it works. How about odd numbers? We're saying the closure property holds for, let's say, addition of odd numbers. What we really mean is that an odd number plus an odd number equals an odd number. So let's try 5 plus 7. That's odd plus odd, and it equals odd. Wait, odd plus odd equals even. So odd plus odd doesn't equal odd. So there is not closure, which means it is not closed for addition. Does that make sense? Hopefully it does to you. If we changed it and we said, okay, what about multiplication? If we have an odd times an odd, does that equal odd? Ah, that works. So we would say it is closed for multiplication, it is not closed for addition. And you can test subtraction. Does it work for subtraction? How about 5 minus 7? That's -2. Even, not closed for subtraction. Division. 11 divided by 3 is not an odd number. It's not an odd integer. That would be a decimal. So we can test all kinds of different numbers, and part of what you're going to be asked to do is to look at different kinds of numbers: rational numbers, irrational numbers, natural numbers, integers, and decide, are these closed? If we do different operations, does the answer we get a member of the set? Hopefully this helps you to understand closure property.